Here. It's time for the review for exam 2. This is going to be covering chapters 6 through 10. There's data that's provided at the end of this review, the last page, and it's comparing the average number of liters of wine that people drink in that country per person per year, and then how many people die of heart disease for every 100,000 people. So take a look at the data. So this, I can't remember, this is something like Ethiopia, where people are not drinking very much wine. There is a lot of heart disease. If you look at the bottom of the list, here is, I think this was Italy or France, where they're drinking quite a bit more wine, and there's less heart disease. So the first thing we're going to do is test for a linear correlation. So put the data in list 1 and list 2, which I've already done here. You should make sure that they're paired up correctly, which I've already done. So for example, just double check. Here's a 1.2 that's across from a 222, 1.2 across from a 222. So just go through the list and make sure that's right. And then calculate and do the linear regression. So we're just using list 1 and list 2. This middle stuff doesn't matter. Move down to calculate. And there we go. So I'm going to write down this information. Excuse me. Here we go. So test for a linear correlation. So we're going to need the R value. So R is equal to a negative 0.874, and then I'm probably also going to need the regression equation, so I'll just write that on the side over here. Y is equal to ax plus b, so negative 23.236x, plus the b is 264.148. So that can just be written on the side over here. That's just fine. This is the main part of part A. So to test for a linear correlation means we need to know the n, also the sample size. So what I could do is just go back to the list, and if I go up, it'll take me to the last one in the list. So there's 24 countries, so n equals 24. Notice when it says test for a linear correlation, it doesn't say what level of confidence to use. So we're going to be using 95% level of confidence, so alpha equals 0.05. And then the graph I make is for R, which ranges between -1 and +1. And then for the critical value, we use table A6, which is the shortest, easiest table to use. All you need is that alpha equals 0.05. And n, notice it's not degrees of freedom, but n equals 24. Hey, somebody just used this table. So notice that they don't have 24, so we're going to go ahead and use 25. So that means the critical value is a 0.396. So on the positive side, it's 0.396, and on the negative side, it's negative 0.396. And then you just see where this R lands. A negative 0.8 would land over here, which means that there is a negative linear correlation. And that basically means as one variable goes up, then the other one goes down. So negative correlation doesn't mean, the word negative just means that they're doing the opposite. So as one variable goes up, the other one goes down. All right, we're done with part A. Predict the amount of heart disease. So since there's a correlation, then we're allowed to use this equation. And then what I'm asking here is either substitute x as a 2 or y as a 2. Well, if you go back and look at the list of data, whatever you put in this column is going to be the x's, and whatever you put in this column is going to be the y's. So right here, this is liters of wine, so that means x. So right here, I'm saying use x equals 2. So just use this equation right here with x as a 2. So negative 23.236 times 2 plus 264.148. So how much is that? Negative 23.236 times 2 plus 264.148. 217.676. 217.676. And then in order to see if that answer makes sense, what you could do is go back to the list of data and see if x equals 2, does it make sense that y equals 217? So if x equals 2, that would be approximately right in here between the 1.9 and the 2.4. Then over here, this says, well, it should be somewhere between like a 266 and a 190. So is our answer between 266 and 191? 217. Yep, that makes sense. So what happens sometimes is, for example, people will get this and the question will be, so what is the person's GPA? And then they get this and they say, oh yeah, their GPA should be 217.6. And I'm like, wait a second, GPA can't be 217. What happens is the person switched X for Y or Y for X or something like that. So just make sure that this answer makes sense. And in our case, it did. Okay, so moving on. Divide those that drink under 2 liters and those that drink over 2 liters. Well, lucky for us, this thing is in order because then the cutoff is right here. So these are the ones that have under 2.0 liters and these have over 2.0 liters. Okay, all I've done is this part. Divide the data into those two groups. Now test the claim that the mean amount of heart disease. So what we've got to do is then take this and put it in list 1 and take this and put it in list 2. Okay, so, or you know what? Since I already used list 1 and list 2, and I don't want to change those in case I need them again, maybe I'll use this as list 3 and this is list 4. Okay, so go to edit, move over to list 3, and now use these All right, so that's the first group. So those are the countries that do not drink a lot of wine. Those countries that drink more wine, here's their heart disease. Okay, now we need to find the average for each group. So we've divided the data into two groups. Those that have under 2.0 liters and those that have over 2.0 liters. Then we need to know the sample size, the mean, and the standard deviation. So go to stat, calculate the one variable statistics, and now I need to tell it second, list 3. Okay, so the average is 246.545. The sample size is 11. The standard deviation 45.992. Okay, now find the mean and standard deviation for the other group, which is in list 4. So one variable statistics, this time second 4, and then calculate that. So 121.146 is the average based on 16 countries. In the S, 61.726. So since the question is about the mean, then what I would do is the group with a bigger mean, I'm going to call that group 1, and this is going to be group 2. Okay, so then test the claim that the mean is the same for the two groups, which means that the alternate is not equals. That's going to make this a two-tailed test. H sub O always have equals. And then because we're testing a claim about the mean, and this is S, then we're going to be using the T table. Use 95% as the level of confidence. Then degrees of freedom. It's going to be the smaller of the two degrees of freedom, so it's going to be 10. Degrees of freedom equals 10. Table A3. Critical value, critical value. So for table A3, we would be using this, that there's two tails, 0.05, and then degrees of freedom is 10. So it's a 2.228. So on this side negative 2.228, this side positive 2.228. All right, now we just need the test statistic. So we can use the calculator for that. Tests, and we need two sample, and it's a t-test. So it's this one right here, number 4. Then you can either type in the data, or you can tell it to use the data in list 3 and list 4. If you don't want to do that, then just type in this data over here for list 1 and list 2. And then whenever it says pool, just say no. Calculate, and the test statistic is a 6.044. So the test statistic, T equals 6.044. So then you see where that lands on the graph, which is way over here, which means reject H sub O, which is a way of saying reject, the two groups are not equal. As you can see, these people have much, much more heart disease, and these are coming from the countries that do not drink a lot of wine. So the two groups, heart disease, are not the same. All right, we're 1/3 done with the test. Next, again using the same data. So test the claim that half. So when it says test the claim, claims can be about a mean, a standard deviation, or a proportion. And this is talking about a proportion. This is saying that it's equal to half or 50%. Whenever it's about proportion, you need to know what's the sample size and how many successes are there. Well, what's the sample size? So when we looked at this list, There's 24 countries, so N equals 24. And then the successes will be those that have over 2 liters. So over 2 liters of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means that the success rate, or p-hat, is 13 out of 24. 13 out of 24. Is that bigger than 50%? Yes, it is. That is over half. Now, is that enough to actually prove that's going to be true in general? So the claim is that the percentage is half, which means the alternate hypothesis is not equals. So that makes it 2 tails. H sub O is going to be equals. And then whenever you're talking about proportions, that is the Z distribution, or table A2. So again, we're using alpha equals 0.05. That's table A2. And if you were looking for this to be 0.025, that is right here. So the critical value is one of the most famous ones. It's 1.96. On the left side, it's going to be negative 1.96. On the right side, positive 1.96. And now we have enough information that we can use the calculator for the test, or the test statistic. Let's see, we need proportions, and there's only one of them. So it's going to be one proportion z-test. So you need to know what is in the claim, 0.50%. X is 13 successes out of 24 countries. This is supposed to be not equals, and then calculate. So z is only a 0.408. So the test statistic, z equals a 0.408, which lands in the middle, which means we're not able to prove anything. So fail to reject H sub O, we proved nothing. Okay, looking at the previous parts, which one is best for explaining what's happening here? Well, I think that I would choose the first one. There's a linear correlation. Since it's negative, and notice that it wasn't close. It's not like this said 0.397 or something really close. It's way, way over here. So it's definitely a strong linear correlation. So that means as X, which was wine consumption, goes up, then heart disease goes down. So I would just write that. So number one, the negative linear correlation shows as a country's wine consumption goes up, in general, the heart disease rate goes down. Perfect, there you go. Now if you were to go on and say something like, because drinking wine then changes somebody's heart, and so then their hearts are healthier, blah, 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 that's where you're wrong. Because that is when you're saying causation is actually proved here. But just because we show that there's a relationship between these two, we're not proving that wine causes heart disease to go up or down. The link most likely is if in a country people can afford to drink wine, then they can probably afford decent food, probably can afford to go to the doctor, their country probably has decent hospitals, etc. So then that's probably the reason that people are not dying of heart disease as much. Okay, then on to something completely different, just questions that are standalone. So in this poll, it says, all right, N equals 8,013 people. So the success here is if they admitted to shoplifting. So X is equal to 646 of them. So then you could calculate the percentage. That's 646 out of 8,013. 646 out of 8,013. 0.081. Or in other words, 8.1% admitted to shoplifting at least once in the last year. Now test the claim. So the claim is about a percentage, and it's at least 10%. So the claim is that the percentage is at least, which means bigger than or equal to, 10%. So H1 would have less than, which is going to make it a left-tailed test. H sub 0 has equals. And as I just mentioned before, if you're talking about a test of the proportions, that's going to be a z-test. So we're talking about table A2. Some of the more famous values, after a while, you just remember. If you don't, then you look it up. You would be looking for 0.05, and there's actually a tie right here between these two. And then the arrow tells you go down here, and if you were looking for 0.05, then the critical value is negative 1.645. There we go. And then we're going to use the one proportion z-test. The proportion is 0.10 in the claim. It's 646 out of 8,013 people. This is supposed to be left-tailed. And then calculate. So the test statistic, negative 5.783. So the test statistic, z equals negative 5.783, which lands way over here to the left, which means we actually did prove something. So reject H sub O. So we're rejecting whoever said it's equal to 10%. Because it landed to the left, it's actually less than that. So it's actually less than 10%. So whoever said the claim, they said it was going to be over 10%. So the claim is false. It's actually under 10%. Okay, we're done with that one. On to the last page. I actually printed mine so that there's a lot more space, so on this video it's actually going to be second to last page. So we've got two groups, the women and the men. For the women, N equals 267, X equals 126 had gotten speeding tickets. Out of N equals 431 men, X equals 299 had gotten speeding tickets. So then you can make the fraction for each one. For the men, 299 out of 431. For the women, it's going to be 126 out of 267. Let's see what that looks like. 126 out of 267, so that's 0.472. And then the men, 299 out of 431 is 0.694. All right, next, construct the confidence interval. So I'm going to make this group number 1 because it has the bigger percentage, 69% compared to 47. This is going to be group number 2. So when I use the confidence interval, which I'm going to have to go down to number, what is it, 8 or 9? Oh, it's actually about the 11th one. 2 proportions, because we have the men versus the women. Z interval. Group number 1 is going to be the men. Notice that here X is written second, but here X is written first. So this is 299 out of 431. This is 126 out of 267. The confidence level was not mentioned, so use 95% as a default, and then calculate. So this is saying the difference between group number 1 and group number 2 is somewhere between 14.8% and 29.6%. So since this side is positive and this side is positive, that means we did actually prove something. The only way you get a positive is if you have a big number minus a small number. So that means whoever this is, they have to have the bigger percentage. And it has to be bigger by at least this much. So the rate, because we're talking about percentages, the rate or the percent, the rate at which men get speeding tickets is at least 14.8% higher than it is for women. And according to the data that's presented, that's about all we can say. Please do not go on and say something like, well, that's because women are better at talking their way out of tickets. No, 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 no. You may have that as a feeling. You may have even experienced that in your personal life. I don't know, but the data says nothing about that. All it says is the rate is higher for men than it is for women. We don't know why. Okay, next up. Getting a bit of a glare here. Let me move this, sorry. So Frank bought 40. I can stop right there and write sample size equals 40. Soup cans. So he found that the average was 11.8 ounces. Wow, this guy really doesn't have anything better to do, huh? Standard deviation is 0.43. And that does say Frank, that doesn't say Greg. That's not me, all right? All right, test the claim that the cans are underfilled. So they're supposed to have 12 ounces. Underfilled would mean they have less than that. So the claim is that the mean is less than 12 ounces. And on this, I can't put equals because if it equals 12, that's exactly what the label said. So the guy's not getting ripped off if it says equals 12. Next, H1 can stay like that, so that's left-tailed. And H sub O would have equals. So it's going to be left-tailed, alpha equals 0.05. Since we're testing claim about the mean, we're going to be using a t-test, so that's table A3. For table A3, we need degrees of freedom, which equals 39. And then we're going to need to use, let's see, this one. Area in one tail, 0.05. And then degrees of freedom was 39. So 0.05 in one tail, 39 is down here, down in the glare. There it is. So it's 1685. 1685. Because it's on the left, it's negative. 1.685. Okay, so now this is going to be a straightforward t-test. That's this one, the second one. And I'll go ahead and type in the statistics. So in the claim, there's 12 ounces. The average turned out to be 11.8, standard deviation 0.43, based on 40 cans of soup. It's supposed to be left-tailed. And then calculate. So it actually made it negative 2.942. So the test statistic t equals negative 2.942. That would land over here. So that means that we did actually prove something. So reject H sub O. Since it's landing to the left, that means that the less than is correct. So he's not getting ripped off by a lot, but he is getting ripped off. So the cans are underfilled. All right, then on to the last stuff, which is pretty much the straightforward how to use table A2. Yeah, all of this is A2. So the mean goes in the middle. The mean equals 152. And then 180 would be over here. So for a single person to weigh, 180 would be right there. And then more than means shade to the right. So then we need to do the z-score. So it's going to be 180 minus the mean of 152 divided by 24. In this, we just use the calculator. I'm going to put parentheses, 180 minus 152, all gets divided by 24. Now when I do the z-scores, this needs to be rounded to 2 decimal places, so this is going to be a 17. Okay, now get table A2. And since this is positive, I need this to be positive z-score. And then look up a 1.17. So here's the 1.1, and then here's the 7 part of it. So 1.17 means that the left side is 8790. So this side is 8790, which means this side is 1 minus 8790. What's that equal? Anybody got a calculator? 0.1210. Is that right? 1 minus 0.8790. Right on. Or if you want to write it as a percent, that would be 12.1%. Next, this is the kind where you work backwards because now you're given a percentage. So the heaviest 2% would be over here. That means everybody else would be 98%. So now what you need to do is use table A2 and look through the middle of it for 98%, or whatever's closest to 98%. That's pretty close. This says 9798. This says 9803. So this is the closest one, 9798. So then you work backwards. The z is 2.05. 2.05. 2.05. 2.05. Z equals 2.05. And then I use the formula that x is equal to the mean plus the standard deviation times the z-score. And so it's going to be a 152 plus 24 is the standard deviation, and we need 2.05 of them. So what is that weight? 152 plus 24 times 2.05, so 201.2, and that would be in pounds, to be in the heaviest 2%. Okay, next, there's going to be a group of 7 women. So the idea is the same as the first one. You say in the middle is the mean, which equals 152. Now they're going to weigh over 145. So 145 would be right here, but it's not one woman, it's an average. So it's going to be X bar equals 145. And then over would mean all of this. So it's going to be an answer that's something like 70, 80, 90%, because it's the majority of the picture. Now the only difference between the first one and this one is that the z-score is slightly different. You start off the same, take the score of 145 minus 152, and then divide by standard deviation of 24, and then because there are 7 women, you divide by the square root of 7. And when I put this in the calculator, this will be in parentheses and this will be in parentheses. So it's going to be, where can I put it? Here we go. 145 minus 152 divided by parentheses 24 divided by the square root of 7 paren. So it's a negative 0.77. And again, I'm just rounding it to 2 decimal places because our table only goes to 2 decimal places. So I need the negative z-score, negative 0.7 and 7 is 2206, which means that this side is 0.2206. This side would be 1 minus 0.2206. So that is 1 minus 0.2206 is 779, and you can leave it in decimal form or say that's 77.9%. All right, there we go.